Our next person at bat is Dr. Phil Jordan. After hearing this presentation a couple of times, he has changed my introduction. He will be presenting on avian influenza in dairy cattle. And I've kind of dropped the highly pathogenic part. So tell me if I've done it better or not. But Dr. Jordan is our extension veterinary with the dairy team. He's one of the newest team members we have. We really appreciate the experience that he brings with us in the large dairy venue. So, Dr. Jordan, podium is yours.
Thank you, Fred. So before we go on, can you see the slides?
Absolutely.
Very good. Yeah, so we're going to give an update right now on the high path avian influenza in dairy cattle that came to our attention last year in March. I've given this 4 times up until now, and this is going to be a little different today because we're not in this same room, but I'm hoping we can make it as interactive as possible. I think it's just going to work better that way. So any of you that have heard this the last couple of weeks, feel free to chime in if you have questions or comments as we go through it. So before we start, I want to just talk about our team just a little bit here. We have Fred up in the Northwest Iowa, Jen in Northeast Iowa, Larry in Eastern Iowa, and then here in Ames, Gail and I, and then Jan Shear is the other dairy extension veterinarian. And I'm really happy to be working with this team. And then also on the extension veterinarian team, so we have Chris Rodemaker, who does pigs, and we have Grant Duell down here in the bottom right, who does beef cattle, and Jan and I do the dairy side. And then we have 2 extension veterinarians on the poultry side, Yuko Sato and Mo Al-Ghazir. And I like to tell this story because when I first started here, they became fast friends. Their offices were close to mine. I was about 1.5 years ago, and I'd say we became fast friends. And then when avian influenza got into dairy cattle, we became really close coworkers. We went from friends to coworkers. Now we're both friends and coworkers, more so than before. As debating what to cover on this topic, there are lots of different things we could put in a half hour, and each one could take that long. So I just listed them here, and if I don't get to any of these things and you have some questions about them, let me know. So the biology of the virus is very interesting. This virus has been around a long time in both human and animal populations, and it's just a very successful virus. It didn't get to be this big of a problem by not being successful. The politics of the virus, which unfortunately this happened right after we'd kind of gotten some COVID-19 fatigue. And so there's some of that in the background of all the things that were going on with this virus. Food safety of the virus, of course, we were worried about that at first. We now know it's been proven what we thought for all along is that pasteurization kills this virus very easily. It's a fairly easy virus to kill lots of different ways, and heat is one of those. And of course, regulatory issues. When this first came up, we didn't know anything about it, and then we had some restrictions on cattle movement, and then aspirin ended up being kind of some collateral damage to the outbreak, and so there's that side of it, and then of course other things about the virus. So any of those things I don't cover and you want to talk more about, please ask some questions about it. So just a bit here about the history. So I put 11 months down because it was in March 26th of 2024 is when it was announced that this had been high path avian influenza had been found in dairy cattle. But a couple months before that, the herds in Texas and New Mexico and Kansas, so down in this part of the country. Can you see my arrow on there? The southern part of the country we started seeing these weird signs in dairy cattle. So um, the biggest signs were decreased milk production and off feed, which, that's not uncommon, right? Almost anything that makes a cow sick makes her go off feed and give less milk production. Um, but the way it would come into a herd and affects a pretty high percent pretty quickly. So it would get up to 10 or 15% just in a matter of a few days. And then the milk would look funny. It looked more like colostrum than regular milk. And it was one of the interesting things about it was it went through these herds very quickly. And after a period of about 3 weeks, it was pretty much gone, and the herds were back to normal. So they were kind of banging their heads against the wall down in Texas. I still have a folder on my computer dated March 15th of 2024, and it just said Texas cattle ill. So something weird was happening in Texas. And then one of the veterinarians there got the crazy idea that maybe this is high-path avian influenza. That came partly because some of the cats were sick and dying on the farms with signs that looked like avian influenza, and some birds on the farms were sick. So they sent in some cats, and then they sent in some milk. And Drew Magstead here at Iowa State tested it for high-path avian influenza, and it was positive. But before the outbreak happened, or before we even knew it was high-path avian influenza, let's say, some cows from Texas had been moved to Michigan, North Carolina, Ohio, Idaho, and South Dakota, and maybe some other places. And unbeknownst to those people that were sending them, they were sending these animals that were infected. And it ended up spreading to those states. And then amongst those states, there'd be little local pockets where their neighbors would be getting infected. So it's pretty fast that this happened. So one of the things when we first found out this was high-path avian influenza last March, we were thinking it'd come north on birds, and we quickly found out that that's not the case. It was we shipped it with cattle. So this map here to the right shows the total outbreak. So notice there's about 1,000 confirmed dairy herds. So it started here in Texas, and it's fanned out to the rest of the country. Colorado is one of the worst hit states there early on. Now, fortunately, it's free. If we go over here to the left, we'll see that these are where the current infections are. So notice there's only 18 cases in the last 30 days. So that's kind of good news. We think we're maybe getting down to the end of this, but unfortunately, in Arizona and Nevada, it's a new strain. So we're still not sure about what's going to happen there. It's a D11 strain instead of a B313 strain. And then Idaho was just added this week. And on the map here, it shows one herd. And as far as I know, it's not been tested yet to see which one it is. So it's interesting that when this hit California, it didn't hit California till the end of August. It was there in August and end of August into September and October. And it was a state that was hit much harder than almost any other state, both in the percent of the dairies that were affected, how widespread it became in the state, and in the severity of it. So a lot of us think that's probably because it was hit there in the summertime, at the end of the summer when it was already hot, and then particularly really hot September and October. That probably contributed to that. If you notice here, this total cases of 978, about 700, some of those were in California. So it's took California a while to show up with this disease, but once they got it, it really hit them hard, probably harder than any other state. So now just a little bit on the virus here. I mentioned that Yuko became a close coworker and friend after this, so we decided to make a pumpkin, and we won the contest at the vet school for the scariest pumpkin. It was a high-path avian influenza model. So these blueberries are H's, which are hemagglutinin, And in the cranberries are neuraminidase, which are the ends. So you hear about these avian viruses, and you hear that they call it an H5N1 or an H5N2, or you hear those all the time. And those are the things that really kind of stand out as really making these viruses a lot different from each other. So we classify them into those categories. Those are both very important for the pathogenicity and the ability of it to attach. But deep inside the virus here, underneath its its envelope, there's these little macaroni things that are RNA molecules or RNA strands. And each virus particle has 8 of those. And there's a couple things to mention here about that. It's an RNA virus, not a DNA virus. And RNA viruses are just really known to be prone to mutate quickly. They just don't have the mechanism to fix errors in that. So it changes really fast. And in these 8 pieces in here, if a cell gets infected with two different influenza viruses at the same time, they'll exchange some of those 8 pieces. And so we get this reassortment. So that's one reason that the human health people are concerned about this, just in general, that it's in dairy cattle now, and just the outbreaks in poultry and everywhere are that can happen and maybe make a more pathogenic one for humans. So we do know that this particular one is pathogenic to people, but right now it's a pretty mild infection. It tends to be just a conjunctivitis, but if it combines with the wrong influenza virus, that could reassort and become more dangerous. So I just put this in to show how complicated these names are, and it goes beyond the H5N1. So this one we're dealing with now is subtype high-path avian influenza H5N1, but it belongs to a clade that's got all these numbers on it, 2.3.4.4.B. So it's a lot of different knowledge about that just in the genotype beyond the H5N1. And then there's a subgenotype here, or a subclade, a genotype, B3.13. And that's the one in this whole outbreak in dairy cattle has been the one that we've seen. But now, unfortunately, we're seeing a new one. Those herds in Nevada and Arizona have a new one called D11, which is one of the viruses that's been affecting the poultry industry this year. So so far, it doesn't seem to be behaving exactly the same, but it's something we need to keep an eye on. This may not be just a once in a lifetime jumping over. This may be something that might be continually happening, or maybe possibly happen in the future again too. So just a little bit here on the testing for this. This first graph is not about the testing. This is about an outbreak. This was about outbreak in Texas, and the dairy owner told Dr. Magstead, "Hey, we've been collecting milk samples for every bulk tank that leaves here. We keep one for our own quality assurance reasons. We keep a sample back. Would you like those?" And he said, "Yes, I really would." So this is from that herd. So this first graph shows the normal number of sick cows that are found daily on that dairy. So this red line here, where we're going between 0 and 8, it's kind of saying that on this dairy in Texas, on a normal day, they had between 0 and 8 cows that were newly sick for some reason going to the hospital. And then this black line here on day 0 is the date that suddenly something happened on that farm that they said, "We've got a real big problem on this farm right now." So if you notice here, they went here in just a matter of a couple of days, up to 30 new sick cows a day, up to 40, 60. And of course, they're adding up because these cows that are here are still in the hospital. So they go from having, normally just a few cows in the hospital to having having 100 in the hospital. So this is the same dairy, and this orange line is the test that we run to check for the virus particles themselves. So that's called a CT value. That's a PCR test, and it's actually looking for the virus itself. And just to make it confusing for us, this test, the smaller the number means the more virus there is. So this number here at the bottom here at the peak of our problem, we were at a 24, which means there's lots of virus in that tank. But what's interesting here, we back up to about 3 weeks, 2 or 3 weeks before the outbreak happened on this farm, and it was starting to turn positive. So we know that when we start picking this virus up on a farm, that in a couple of weeks, there's probably going to be a problem that's going to be clinical signs. So this means these animals are incubating for a while and spreading it amongst themselves before we even know that there's a problem on the farm based on the clinical signs. And in this blue line, this is testing for the antibodies. So just to be confusing on that, it's the sample to negative ratio. And the smaller that number is, the more positive it is too. So out here before we had this outbreak, we're up here at 0.9. And then during the outbreak, we get here below 0.6. So about the time we're noticing that there's a problem on this farm, the antibodies are changing and becoming present. So what's really cool about this, and I want to brag about the Iowa State's Diagnostic Lab, Dr. Magstad and Dr. Peterson at sending the samples of this to begin with, and the dairy that sent these samples, is that we can really tell where a herd is based on this samples. So out here, if they're both negative, both high values, we know that this herd's not infected currently and has probably not been infected, at least very recently. Here in the middle, where we have the orange line coming down here, the CT value of the polymerase chain reaction, if we find the virus in there, we know that herd is actively infected. And then out here, we can tell that this herd is recovered. We're not finding the virus particles anymore, but we can find the antibodies. So really, that's pretty cool from a standpoint of having a pretty good test and showing that the test actually works really well to find this virus. So in December of this year, the USDA announced a silo testing program. So these are silos filled with milk at processing plants. And as of March 5th, these are the states in the lower United States that are taking part in it. North Dakota and Florida are soon to be added to it. And Massachusetts is not on the list, mostly from a technical the technicality on where they test, where they send the samples. They've been testing every herd for months. So it's that's kind of a technicality. And just to point out that when we first started Dairy Days, Idaho, Minnesota, Idaho, Wisconsin, and Illinois were not testing yet, but they've since started testing. And from those tests, here's what our currently think about the United States. So Colorado, Mississippi, and Pennsylvania have been testing long enough and through labs that the USDA deems as qualified. And they've been doing that for months, so that they've turned yellow here. Michigan and Texas still find some little virus particles in there, so they're not, they're still considered positive. And then, of course, we have this outbreak in California, Nevada, and Arizona, which probably take a while to get rid of. But over the next few months, I think we're going to see a lot more states turn yellow. And I think this is a pretty good statement that or pretty good deal that the USDA started to help us know which states are infected and find out quickly when they become infected. This diagram came from the USDA's website, and I really like the diagram because it kind of shows what's happened in this outbreak. The big point up here on the very top, this virus may be imported, so it shows a truck here, and that's exactly what happened. We moved this virus from Texas or the South West United States, Texas, New Mexico, and Kansas, to other states. And then once it gets there, it spreads between herds. We don't really know how that exactly happens. The rest of this is a little bit fuzzy, and I'll talk about that in another slide. But notice they have a X through this duck. It was pretty quick that we realized that the waterfowl are probably not the biggest spread of this. Now we might be rethinking that now that we have this new outbreak in Nevada, but at least for most of this outbreak this year, it was not in birds. In fact, they found this in birds in late 2023, but now they cannot find it in the wild bird population. And then just to show over here to the left here, there's lots of different animals that can be affected with this. Most important to our dairies are the cats. So there have been reports of the cats that are stray on the dairy that we don't necessarily want, but also some of the dairymen's pet cats have been affected by this, and it's a dead end for the cat. It's usually leads to their death. There have been reports of it spreading to poultry flocks, which can happen, and maybe it goes the other direction also. So I think it's part of something the dairy industry needs to be thinking about, is that we're in this with the poultry industry now, and we need to get under control together. The USDA announced last week a new plan to put $1 billion into new plans. This is on the poultry side, so it's going to be to boost biosecurity, more indemnity for repopulations, money into innovations, so getting vaccines. And people ask about vaccines all this last couple of weeks. There are companies working on vaccines. Elanco just announced a joint effort with MedGene, and then Zoetis just got a new vaccine for poultry. But that's not as easy as you might think. That there's just a vaccine, that means it's going to be a cure, and that everybody's going to love the vaccine and want it. There's a lot of trade implications there. There's a lot of testing implications. There's a lot of things that have to be worked on before we can have a good working vaccine. So I just put this in as a summary of what we know, don't know, and surprises from this outbreak. And I think it's pretty cool that we found out so quickly that it was high-path avian influenza H5N1 causing this problem, and had it sequenced down to every base pair in the RNA, or every base in the RNA. We thought it was a single spillover, and we still think that, at least from the original outbreak. But now with this new outbreak in Arizona and Nevada, that's why I put the question mark there. We did find out, though, in the webinar last week that Fred sponsored there, that the herds in Nevada did not seem to be as affected as the other herds at the previous outbreak. So hopefully it's not as pathogenic. The only thing we know is that it's shed in milk. That seems to be the only place we can find it consistently. What we don't know is how it gets into the next animal. I think we know probably how it gets out of the cow. It gets out in the milk, but in how it gets into the next cow, we're not sure of. It could be oral, respiratory. It could be in the milk. We've proven out here at the National Animal Disease Center that can happen, but that may not be totally true in the field. Their experiments when they milked a cow that was infected and tried to spread it to the next cow by using the same milking unit, it was not spread that way. All right, so surprises. Surprised that it was spread by cows, not birds. When we first put on webinars right after this happened, we had in our discussions, we had the bird people come in and talk about how we could control the birds on dairies. We now know that probably not the main way, although with this new outbreak in new version in Nevada, maybe we have to rethink that. The genome seems to be pretty stable. During this whole outbreak, when it was the B313 outbreak, it was pretty much the same the whole time, which is really good for a vaccine development, that we can have just one strain that's causing the problem. When we humans get vaccinated, there's the CDC tries to make a good guess of which of the influenza types are out there to put in that on that vaccine. And I think that with dairy cattle, we could probably just put that B313 in there, or then maybe add the D11 after we find out more about what's in there. Jen keeps this website up if you're interested in finding out more information about HPAI. There's links in there to the USDA sites, the IDOL sites, and other information. 2 weeks ago, Dr. Caitlin Sarlo-Davila did a seminar for us, a webinar, and that's been recorded. So if you're interested in that, you can hear it. She gave a lot of good information on the immunity, the immune response, how we think it's spread, and just a lot of good information there. All right, so that's it. I'll take any questions from anybody if they have any.
If we have questions, just go ahead and unmute. That's probably the easiest way right now.
All right, so I see a question here. It's vaccines for which species? So right now, the two animals we'd be interested in are poultry and dairy cattle. And the Elanco-Medgene agreement is for dairy cattle vaccine development. The Zoetis one that they announced is for poultry. Across the world, there are some countries that do vaccinate for high-path avian influenza in poultry. France is one of those. They use it in the duck population there, but not the other ones. And that does create, when you vaccinate poultry animals with it, it brings up a lot of questions with trade. And some countries don't want to buy our poultry products if we vaccinate instead of just eliminate it from a herd when we find it. There's a couple reasons for that. You think about it, if we vaccinate with highly pathogenic for highly pathogenic avian influenza in birds, and then we have a pretty good protection, we won't be able to tell if it's in there circulating, and we might be causing it to stick around even more. So that's one of the reasons the export markets are affected by that. There is a different opinion between the different the poultry people on that. If it's mostly for domestic purposes, so that's where most of the eggs stay here and most of the turkeys stay here, they're more for vaccinating than the ones that are for seed stock and but for broilers that have more of an export market. But those are all things that need to be worked out, both on the dairy side and the poultry side. It's not a simple, we have a good vaccine, we're going to use it kind of thing.
Dr. Jordan, thank you very much for the information you presented.